Hey maths fans, we're looking at the sine rule today, which is a bit of trigonometry, and hopefully you've already looked at right angle trigonometry with SOHCAHTOA, and finding that sine is the opposite over the hypotenuse. Sine of an angle is the opposite side divided by the hypotenuse. If you know that, we can apply that to any right angle triangle and derive a new formula, one that works in any triangle, doesn't have to be right angled. So I'm going to start with this example here. So we've got the sine rule that we're going to look at, and this triangle I'm going to label it up. And the way I label it is, first of all, put capital letters A, B and C on each of the three corners. So capital letters A, B and C on each of the corners. There we go, A, B, C. And then opposite each of those letters, so opposite the capital letter A, I put a little letter A for the side A. Opposite the capital letter B, I put a little letter B for the side B, and opposite C is side C. Okay, so we've got three sides and three angles, A, B and C, and little a, B and C for the sides. Capital letters on the vertices, or the corners, and little letters on the sides. Now, choosing which one is A, B and C is quite a useful thing to do. You can label any one of them A, B and C as long as the side opposite it is the lowercase of that letter. Now, if I split that triangle up like this, so I make it two right angled triangles, I've just drawn this line down here. When I do that, I can now apply my right angle trigonometry to this triangle. So what have I got here? Well, if I consider this angle A here, I know that sine of angle A is the opposite over the hypotenuse. Well, in this case, the opposite is that line that we've drawn down there, x, opposite over the hypotenuse. And here the hypotenuse would be C, because there's my right angle. So x over C is sine A. Now if I rearrange that a little bit, I multiply both sides by C, multiply by C, I get that C sine A equals x. So if I had a value for the side C and an angle for A, I can find that length x. So if we kind of consider this as the red triangle, let's draw a blue triangle here. So now I'm going to look at the other side of this, and I'm going to use the same ideas, but with this blue triangle here. So I want to come up with a formula for x here. Well, I know that sine of angle C is equal to the opposite over the hypotenuse. Opposite is x, hypotenuse is A. Okay, little rearrangement, multiply by A, multiply by A. And I get A sine C is equal to x. Now what's lovely about this is if we've got two different formulas for x, if A sine C equals x and C sine A equals x, they are the same also. So this C sine A is equal to A sine C. So C sine A is equal to A sine C. Let's write it over here. C multiplied by sine A is equal to A multiplied by sine C. Now a little rearrangement of that formula. If I divide by A and divide by C, I get that sine A over A equals sine C over C. And we've just come up with the sine rule. And the sine rule states that sine A over A is equal to sine C over C. And that can help us to solve all sorts of problems. We can go even further with that. If I split up the triangle differently, I can actually find that sine A over A is equal to sine B over B is equal to sine C over C. And I can flip those upside down, and say a over sine a is equal to b over sine b is equal to c over sine c. This is the sine rule. Now, one of them's more useful or quicker for finding sides, one of them's quicker for finding angles. But as long as you have any of these basic relationships, if I just take the a over sine a equals b over sine b, if you can use that, you can solve all sorts of problems with triangles. Let's go back and kind of think about what that means. C over sine c, well, that means the kind of the ratio between the opposite length and its angle is always equal. Okay, so if I do sine of this angle divided by this, it's the same as sine of this angle divided by this. So those ratios are always the same in a triangle if we use the sine rule. Let's go on to look at some examples of how we can apply this. So, this one I'm using lengths. So when you're using lengths, put the small letters on the top. The little a's, the little b's, the little c's. Now I can choose which of these corners, which of these vertices is A and B and C, and I like to make it convenient for myself by making the thing I'm looking for the A. Okay, so I'm going to first of all label this as my A, which means that this must be my angle A. Then I've got these two sides here, this side and this angle here, so I'm going to call this one B and this one little b. And then I don't actually need C and C in this example, but we'll label them up there, C and C. So my recommendation is that you always make the thing you're looking for A or sine A, or capital A or the little a. Okay? What we can now do is apply this formula. So A is what we're looking for, that's x. Over sine A, well, sine A is 92. Over sine 92 equals B over sine B. And remember, little b is the length, so 30 over sine 46. Now, if you've got a graphical calculator, you've got an equation solver, we can actually just go straight to the equation solver and type this in. I'm just going to rearrange this because as a mathematician I like to make things a little more convenient. So in this case, if I want to find x, let's get rid of this divide by sine 92 by multiplying by sine 92. Multiply by sine 92. And so I get x equals 30 times sine 92 divided by sine 46. Now I'll show you how the two methods I can do. I can type this into my calculator, press equals, or I can go to the equation solver and put the whole thing in. So I'll show you the kind of the proper way, as it were. So we'll go here. Now, if you're using a graphical display calculator or any calculator, make sure that you are in degrees for this. If you're finding angles in degrees, you need to set up. So we'll go Shift Menu and we get to this setup. And then angle at the moment says rad for radians. We're going to change that to deg for degrees. Now that I'm in degrees, I'm going to type in 30 sine 92 on top of a fraction, 30 sine 92 on the top, and then I'm going to put on the bottom sine 46. And then press execute. And there we go, we get 41.7. Let's check that's the correct answer. There we go, 41.7 centimeters. We found a length there. Now I'll also show you how to do that if you want to skip a step and go straight to the equation solver. Absolutely nothing wrong with that. If you've got the technology, why not use it? So now we'll go to Menu and Equation. And here, again, you still need to make sure that you are in degrees. So just check the top of your calculator says deg and not rad. Any trigonometry, make sure you're dealing with deg if you're doing degrees, or rad if you're doing radians. So here I'm going to try and put this in. So I'm going to put fraction x over sine 92. And then I'm going to put equals, shift equals, and then I'm going to put 30 over sine 46. and hopefully we get the same answer using this method. So click solve, and there we go, 41.67, which rounds to 41.7. So that's the two ways that you can use your calculator to do the calculations. I think it's important to understand how we rearrange to make x the subject, to solve it. But equally, if you've got to this point and you can solve it with the solver, use the solver. Why not? Okay, here's one for you to try then. So pause the video now. Maybe you go back if you need to remind yourself how we did this. Label it up carefully. Choose which one you want to make A, B, and C. Technically, it doesn't matter. You can do any one, but it makes your life a lot easier if you make A the thing you're looking for. Give it a go, and then I'll show you the answer in a second. Okay, and here is the answer for this one. So I would have labelled it as little a here, big A here. And I would say big B here and little b here. And then I would say that A over sine 40 equals B over sine 42. Either rearrange that or type it straight in your calculator, and you should get an answer of 28.8 centimetres. Okay, moving on. We can also use this to find angles. Now, you'll notice that we're using the slightly different formula where the sine of the angle is on the top. So if you're looking for angles, put the big letters, the angles, on the top. If you're looking for little letters for the sides, put the sides on the top. Although, actually, if you're using the graphical calculator, probably makes it not matter that much. Right, for this one, we're going to do the same thing. This time I'm looking for angles, so I'm going to call that one A. The thing I'm looking for, I make A. Just, you don't have to, it's just what I like to do. Then we're going to say this one's going to be B and B. So now I'm going to say that sine A, now sine A is the angle X, over A, which is 5.5, is equal to sine B, and sine B is the angle 100, over 7. Now, when I rearrange this one to make sine X the subject, I get sine X, so I'm multiplying by 5.5 here, equals 5.5 times sine 100, all over 7. Now, I haven't actually made X the subject. I haven't made the angle the subject. I've got sine X as the subject. So when I type this in my calculator, what I need to do is inverse sine brackets. 5.5 sine 100 over 7. Okay, we've got to find an angle, we have to press shift sign. However, this equation solver means we can probably type this in. Let's see if it works. So let's exit that and let's delete everything we've got. So let's try typing that in. Let's go for sine X over 5.5 is equal to shift equals sine 100 over 7. And let's see if we can solve that one. Are we in degrees? It's given us 50.7. Well, let's think. Does that sound sensible as an angle? I'd say so, yes. I'll also show you how to do this without the equation solver. So let's just check that we've got the right answer there. Yeah, 50.7. If we did it without the equation solver, so we go back to the menu and just in the normal run function, I need to do that shift sign because I'm working back from sine. I'm doing the inverse. Shift sign and then brackets, and then we'll put in all of that stuff. So 5.5 sine 100. On the bottom, we're going to have 7. And then I'll close my brackets and press execute. And we got 50.7 again for the angle. So there we go. That's finding an angle using the sine rule. One last thing for you to try. Here you go. So pause the video and have a go at this one, and I'll very quickly give you the answer. So pause, and I'm just going to go straight to the answer. It's 40.9. That's the sine rule. Thanks for watching.